Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy. This is our 9th video in our index laws series. We're looking at another application of index laws by talking about significant figures. Now, you can actually talk about significant figures in the context of rounding, of normal numbers. However, we're going to be doing this in the context of using scientific notation. We're bringing those two concepts together. Now, if you haven't watched the last video, video 8 on scientific notation, you're going to want to get your head around that one first, because you won't understand that if you haven't done it first, and significant figures is kind of like the tag on for that one. Okay, so first of all, let's talk about what significant figures are. Well, as I've mentioned, it's another method of rounding, and we often use it in science. It's often used in terms of just normal numbers, but it can also be used in the context of scientific notation. And once again, it's a method to round those very large and very small numbers that we often see in scientific contexts. Now, we're just going to unpack a little bit of vocabulary here with the word significant. What does that mean? Well, if you're a significant person, it means you're an important person. And in mathematics, what we're talking about is rounding extreme numbers, very big numbers, very small numbers, to a level of accuracy that we deem important as the person who's doing the rounding. So as we mentioned in our previous video, if we looked at things like the distance to a faraway planet, it's in trillions of kilometers. Maybe that's the distance a light travels in 1 year, for example. It's not important necessarily to know every centimeter in that journey if we're just talking about it or if we're just referring to it. So we only want to talk about the most important numbers, which are usually the very first couple of digits. They're our significant figures in this case. And that would be the level of rounding that we would chop off our numbers to. Okay, now we've got some rules to memorize. I know everyone hates memorizing things, but sometimes you've got to do that in maths. So with significant figures, our first rule is we always count from left to right. Okay, so for example, if I wanted to round the number 12,345 to two significant figures, I count from the left, which is over here, the number 1, and I count to the right. And if I wanted to do it to two significant figures, we can also call them sig figs. Then the first numbers, 1 and 2, are the first two significant numbers. So that means I'm rounding to the thousands column. So these are our first two significant numbers from the left to the right. So that means I'm going to round to that level there. So the number 1, 2, 3, 4, 5 becomes 12,000, rounding it to two significant figures. Now, let's get on to some more rules. So we start from the left to the right. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 through to 9 are called non-zero numbers because they're not zeros. They are all significant figures. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all significant. So in our previous example, 12,345, there's 5 significant figures in this number. All of those numbers are significant. If I was to round that to one significant figure, that means I count from left to right, and the first number is the only number that is the significant number that I'm rounding to. So that would become the number 10,000. If I wanted to round to two significant figures, then I'm going to count from the left, 1, 2. So that means I'm going to be rounding to this level, 12,000. Rounding to three significant figures, I count from the left to the right. Then I'm going to be going 1, 2, 3, 0, 0, 12,300. So as you can see that the more significant figures you have, the more accurate my answer is going to be. The less significant figures, the more rounding that's taking place. So for example, here, when I'm rounding to one significant figure, it's close to the number 12,345. In fact, it's to the nearest 10,000. However, it's 2,000 off. Okay, so it's approximate. 12,000 is much closer to 12,345. So it's a greater level of precision than when I add more significant figures in. We're now going to round to the fourth level of significant figures. And you might be thinking, well, that's fairly straightforward. In all the other cases, we just chopped off after the fourth significant figure and replaced it with a 0, because you notice when we did one significant figure over here, the numbers 2, 3, 4, 5 became zeros. In this case here, the numbers 3, 4, 5 became zeros, and here, these two here became zeros. You might be thinking, well, that's fairly straightforward then. 1, 2, 3, 4 significant figures, the answer is going to be 12,340. However, we still need to look to the right-hand side of our last significant figure, the fourth significant figure, this 5 tells me I need to round this up to a 5 as well. So it's not just a matter of keeping the 4 and changing that to a 0. There's always that odd case there where I've got to round one up. So always be careful to make sure you look to the right of that last significant figure, and those normal rounding rules that we've learned in previous years will apply there. And that's because 12,345 is classified as being closer to 350 than 340. Okay, so it's not smack bang in the middle, it rounds up to the 350. Now, if we had to round to 5 significant figures, well, we're not really rounding at all. 5 significant figures is just our original number because they were all significant. And something you'll also notice, as I've mentioned already, that all those numbers that were also significant, because remember I said that all those numbers, 1, 2, 3, 4, 5, are significant numbers, but I'm rounding to certain levels. These now become zeros. They don't just simply disappear. So that's something very important to remember. So you'll notice that when I round 12,345, I rounded it to 12,000, not just to the number 12. 12,000 is a rounded form of 12,345, but just the number 12 is nowhere near 12,345. Nowhere near it at all. I've completely changed the number. So we're not just chopping numbers off and making them disappear. We're replacing them with a 0. We've still got those place values being held. Just taking these numbers away and disappearing them is not rounding at all. Okay, now we've talked about the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, all significant figures. We do our significant figure rounding from left through to right. But we've got some special rules. In fact, 5 of them about zeros. And this is where you're going to have to do some memorization. Because the other stuff was easy to remember. But zeros, the rules are a bit weird. Okay, so first of all, any zeros between non-zeros are significant. Now remember what a non-zero is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So any zeros in between them are classified as significant numbers. So a 0 between a 2 and a 4 makes the number 204. All 3 of these are significant figures. So if I asked you to round this to 3 significant figures, the number would just be 204. If I asked you to round this to 2 significant figures, I'd be chopping off at the 4 and changing that to a 0. That would become the number 200. And if I asked you to round it to 1 significant figure, it would be 200 as well. So zeros between numbers, significant figures. Trailing zeros. Now, trailing means they're numbers that are behind. Okay, so if someone's trailing behind me, they're behind me. So trailing zeros after a decimal point are also classified as significant. Now here's an example. So notice here I've got the number 8 and I've put a decimal point there. If I now write some zeros after it, they become significant figures. So in this particular example, you can see there are 3 significant figures, the 8, the 0, and the 0. Now, if I don't put that decimal point in there and just write it as the number 8, the rule is going to be different. So what makes this work is that decimal point. That decimal point is critical. So these rules are all about where that decimal point is. It's very important to watch out for. Okay, now the next one, trailing zeros before a decimal place are also significant. So you'll notice here, this is a trailing 0. It's trailing after the number 7, and there's a decimal point straight after it. So it makes it significant. Okay, so you've got to work out where that decimal point is. If anything is after it, anything is before it, that decimal point makes it significant, makes those zeros important, before and after. So that decimal point's what you've got to be looking out for. So those are our significant zeros, between non-zeros, after the decimal point, before the decimal point. Now, these are the non-significant zeros. If I've got trailing zeros and there's no decimal point at all, they're not significant. So here's an example, the number 600. 6 is significant, but the 2 zeros are not. If I put a decimal point in there, those 2 zeros become significant. If I take the decimal point away, they are not significant numbers. So the number 600 has 1 significant number in it. Our other rule, leading zeros are not significant. So in this particular case, 005 and 0.6, they are leading in front. There are nothing going before them. And 0.003, they are not significant zeros. So in this case, we've got one significant number, one significant number, one significant figure here as well. Okay, so you've just got to get your head around those rules. Now you might be thinking, well, how is that different? We talked about trailing zeros on the previous one with a decimal point. That's different because they're trailing after a number. So if it was 50.00000, then the zero before the decimal point and the zeros after, they are significant. But in this case, these are not trailing, they are leading. So the trailing and the leading is very important. Okay, you might be thinking, well, that is a lot to remember. I can't do that. And yes, it is a lot to remember. And that's just the thing. You need to memorize the rules. I highly doubt anyone's going to write those rules for you in your exam. You just need to memorize the rules. There's only a half a dozen of them. So once you've got them nailed, you should be fine. And the way to do that is lots and lots of practice. The more you practice, the easier it gets. I would suggest you go back to the beginning of the video and maybe take some screenshots of the rules and then write them down, stick them up somewhere important like your bathroom mirror, next to your bed, so that's the last thing you look at every night, and that way those rules get into the grey matter. Okay, McClutchy Maths viewers, I know that's been a lot to take in this particular video. We've looked at some really weird rules. We've talked about a lot of rounding. So we're just going to pause it there for the moment. Come back to watch our next video where we're going to actually bring in the knowledge that we've learned with significant figures and scientific notation together. If you've got any questions at all about anything you've seen in this video, or you want some help with a little bit of that sig figs and rounding, here we are, mcclutchymaths@yahoo.com. Best place to reach me. Well, thank you so much for joining us today. Have a wonderful day.